Hello and welcome to the fourth video in the current VTOL series. Now this again is my first VTOL series. I am picking the brains of this gentleman here. This is Ben from 3DXR. He is an expert, a Jedi master at creating VTOL systems. He builds and sells large, expensive UAV systems for things like agriculture, engineering, surveying, universities, education, and those are shipped all around the world. So he has an awful lot of experience and he's been incredibly generous with his time to spend 2 pretty full days with me shooting this series, passing on his expertise. The idea with this, of course, is that once I've sucked all that fantastic knowledge out of his brain, then we'll go on to the next series and I'll try and build my own. And that, I think, is where we'll really learn where all the little tips and tricks are. But a big thank you to Ben for putting aside 2 business days, which he could have been using to sell his own stuff and run his own business, to kind of share this knowledge with me and you as well. So in this video, it's all about the final bench checks, and Ben started to talk about the different flight modes that he uses and how he sets it up and his plan for the maiden flight in quite a bit more detail. Now the next video in the series, the last one, is that maiden flight, and he's going to be referencing a lot of the information that he's discussed in more detail in here. So don't start with this video, start at the beginning, because it kind of explains and builds on each video piece by piece. And also this series is definitely not aimed at those of you that have never built a quadcopter or a fixed wing or anything Ardu plane based before, because Ben is an expert and the kind of detail he's providing is kind of the high level super duper stuff. So if you haven't already done some Ardu plane stuff, there's other series. I'll put links down below if you want to go and have a look and check that out. In the next series, where I build my own, we're going to find out an awful lot of those extra little wrinkles. But let's get on to the bench and let's hear from Ben about the tips and tricks and the way he sets up the model ready to go to the field for those first few flights.
Okay, so today we're going to go through the maiden flight of this VTOL, which you saw in our previous video. We're going to have a look at the initial sort of testing and the flight modes that I used to carry out this maiden flight. So last time we'd done some motor testing, we'd tested all the control surfaces, so now let's look at the next step. In addition to the traditional fixed wing flight modes such as fly-by-wire A and B, we also have these flight modes with a Q in front, so we've got Q stabilized, hover and loiter. So my first steps would be, once we've happy all the motors are turning in the right direction, all the controls are correct, would be to do an initial hover of the aircraft in Q stabilized. So Q stabilized mode is a quad plane mode, a multi-rotor mode, and it's going to loosely level the aircraft. The throttle in Q stabilized is the same as in stabilized on a copter. It is direct sort of pass through to the throttle stick move. So middle stick is not hold height, it would be 50% throttle and whatever action that is on the plane. So in Q stabilize, I would be very active on the sticks, and I would raise the aircraft up off the ground, and I'll be checking that it responds to the stick inputs correctly to roll, pitch and yaw, and also looking at its stabilizing self. If there was any vibrations at this point, they would need to be addressed in the PID settings using the guidance from the Ardu Pilot website. If I was happy with how it behaves in Q stabilized, I would then move on to Q hover. So Q hover is like an altitude holding mode. So its copter equivalent would be alt hold or ATI or ATI hold in other drones. The aircraft is going to level itself, and it's also going to hold height based upon the barometer height. The throttle stick will command changes in heights, not necessarily a throttle percentage. In Q hover, we'll initially take the aircraft off, again make sure there's no excess vibrations, and then look to hold the aircraft for a minimum of 30 seconds so it can learn the hover throttle. This is probably one of the most common modes that will be used later anyway, would be Q hover. I'd also then look to carry out the initial tuning steps, again following the guidance on the Ardu Pilot website. So it'll be making changes to the PIDs and also the other parameters that affect the behavior of the VTOL. Yep, so there's two types of auto-tune on a VTOL. You don't have to invoke auto-tune from Q-hover. It can be done from Q-loiter and from other flight modes. So we have Q-auto-tune, which is the quad plane, which is a multi-rotor auto-tune, and it'll go through its pitch, roll and yaw axes. It is scarier. It is a good way to do it. Once you've got rid of any initial vibrations on the aircraft or any shaking or oscillation, that must be manually addressed. But absolutely, I do use Q auto-tune. There is also the auto-tune as a fixed wing, which should get to today as well. So we've looked at Q stabilized and Q hover. The other one in our list here is Q loiter. Now that is the same as loiter in a multi-rotor. So that is a GPS position holding mode. It would be like a GPS mode on a multi-rotor. So that's where if you take your hands off the sticks, it will remain in place even when being blown at by the wind. So that's the main Q modes, the modes where the VTOL is behaving as a multi-rotor. The other modes I will set up on the transmitter. So as you can see in this video here, we're connected to Mission Planner, and we also have, in this case, it's a adhere link, which it has these modes labeled on. So I have my Q modes. I have fly-by-wire A and fly-by-wire B. If there was a mode that wasn't assigned to a switch, so if you notice here, I don't actually have Q stabilize assigned to a switch, I can invoke that mode from Mission Planner or Q ground control, where I can go and change my flight mode to Q stabilized and set the mode.
Plane stabilized flight mode.
As you can see, I've changed it on the laptop. It has changed on the flight controller, and I've had feedback from the adhere link. I can then get out of that mode by changing into any other mode. So that might be, I don't want to accidentally go into Q stabilized in a fully set up and tested drone, so I don't put it on the stick on the radio as a permanent flight mode. I also don't want customers to accidentally press it. It's a flight mode that requires more active flying. You can't just let go of the controls, something will happen. So when I'm doing my setup, I'll invoke Q stabilized from Mission Planner or Q ground control. It's the same as well if you wanted a manual fixed wing flight mode. I would invoke it from the computer and not put it on a button for somebody to accidentally press. So the fixed wing flight modes that I've got available on the remote is fly-by-wire A or FBWA. That is a leveling flight mode, very nice to fly. Throttle in this case is sort of directly passed through, so zero throttle will stop the motor. Full throttle is 100% and middle stick is 50. So you normally have to adjust the stick to find the right speed. Fly-by-wire A is good on a ratchet throttle. I quite like fly-by-wire B, and I leave that on for most customers. In fly-by-wire B mode, it holds altitude, and middle throttle is the cruise speed. So in this particular case, this VTOL flies at 18 meters a second cruise. So if you just take your hands off the sticks in fly-by-wire B, it will remain straight and level at the cruise speed. If you put the throttle to 0, it will hit the fly-by-wire minimum speed. In this case, it's about 12 meters a second. If you put the throttle to the top, it will hit the fly-by-wire maximum speed, which is about 25. Fly-by-wire B mode is very similar to the way a Parrot Disco flies. This sort of leveling, height holding mode. So it's very good for beginners. You can fly circuits where you just have to concentrate on your banking, and then you can progress to other modes like A, where you would need to hold your height and throttle, and then there is the sort of stabilizing and manual modes in a plane. The way I view VTOLs, this one we're looking at today, the purpose of this is a mapping plane. We don't do aerobatics with it, sadly. So these are the main modes we've seen here, the Q modes and the fixed wing modes. And let's have a look at our transitions. The first transition we'll do for me would be from a Q hover, so a multi-rotor mode, a quad plane mode, over towards a fixed wing mode. So what we'll do today is we'll do a Q hover to a fly-by-wire A. This is a forward transition. So what happens as soon as, let's say we take off to 30 meters in Q hover, I would then press fly-by-wire A. The front motor will come on. Now, a very good setting to have is a slew rate. So this drone here has a 40% slew rate. What that means is it can't apply throttle faster than 40% a second. I've seen people where they have, big powerful motor on the front. It instantly demands 100% throttle, and that can be quite aggressive for a sort of in-air takeoff, if you like. And in this case, yeah, about 40%. It's a nice parameter to have. It smooths the throttle, so it can't instantly demand full power. That's also important because in this particular aircraft, it's a common battery bank that's powering both the VTOL, the multi-rotor motors, and the forward thrust. If you can imagine if everything suddenly went to 100% throttle, it's a big drain on the battery as well. So it's a nice way to do it. So yeah, we'll get this forward transition. Q hover, we'll press fly-by-wire A, the front motor will engage, and the aircraft will start to go forward. When it reaches fly-by-wire A min, or fly-by-wire minimum, sorry, so in this case it's about 12 meters a second, those VTOL motors will start to disengage, and there's a delay of about 5 seconds, and then they will be fully shut off. At that point, the aircraft is flying as a plane, and the control sticks are now, it is in fly-by-wire A, it's an aircraft. The quad motors have shut off. You have roll and pitch like if it's a fixed wing. This is also an area where if you build your own aircraft and you don't set up the minimum and maximum airspeeds, this is where your transitions, you could result in the motors turning off too soon, where you would have a sort of dive towards the ground, or an extended period of time where the VTOL motors maybe don't turn off, and obviously that's a big power drain. So these are parameters that you have to put your best calculation into what they should be. So fly-by-wire minimum speed should be, say, 10 to 20% above a stalling speed. Maximum is the maximum speed you want the aircraft to fly at. That could be specified by the manufacturer of the frame. So in this case, something like 25 is good, 27 would be okay. But like I say, this thing cruises around at 18 meters a second. So I've got a minimum speed of 12 and a max of 25. So once this registers at 12 meters a second forward speed, it then keeps the motors on for another 5 seconds. That parameter can also be adjusted. Then it would shut them off, and it's a fixed wing. So that's a forward transition going from Q hover to fly-by-wire A. It would be exactly the same from loiter to A. And again, going into B, the only difference is once it's complete that transition, B is going to try and hold the same height, and if you leave it in this case, so I like to use a self-centering spring. Once I press fly-by-wire B, it's just going to keep going at that 30 meters transition height, and until I raise it up, or so we'll go through those modes.
So one question that I have about this then is that you really need to understand the flight characteristics of the fixed wing before you start bolting motors onto it. Because unless you have an idea of what that stall speed is, it gets really difficult for you to manage your transitions. Yeah,
and you'll likely have changed some of those flight parameters by taking a normal plane and adding
a ton of drag.
Yes,
a ton of weight. Okay.
Exactly. Right. So if you took whichever aircraft it is you made, or let's say a Talon or something, and then you stick the motors on it, you upset the drag, you've added extra weight to it, those parameters might change. So you could urge on the side of caution when you do that. So on our first little flight, what we'll do is we'll do this forward transition. If at any point you just need to stop, flick it back into a quad mode, and those motors are going to engage. You'll still be moving forward a little bit until it can brake and stop, but it's not going to fall out the sky as a plane. The one bit you can mess up is if you went from a quad mode to a manual fixed wing mode. That would instantly chop off the VTOL motors, and it would engage the front motor depending on where your throttle is. But that is the one where it would be likely to crash on your maiden. But it could also be a mode where it saves you in the air if something else was going wrong. So that sort of mode, in my case, I would only invoke it from the ground station for a mission planner or from whatever. It's not a button where someone can accidentally press it. In our little table of flight modes here, there is 3 more modes. Now, this is one to catch people out. Loiter. This doesn't have a Q in front of it. It's not a multi-rotor mode, it's a fixed wing mode. Loiter is a circle mode, a GPS circling mode. So there is a circle mode, but loiter is circling around a GPS point. The reason I put that there on is for safety. So most of my flights with these VTOLs involve large survey missions, flying grids. And if I needed to interrupt that, say there's incoming air traffic or something I need to hold off, I find the best way is to put it into loiter mode. So this would be a mode that I would put in while flying as a fixed wing. And this would just start flying in a circle. So where you engage loiter becomes the center of the circle. Then it's going to fly the loiter radius. So that's a nice way to hold the aircraft somewhere. So that should be engaged when you're a fixed wing. The radius can be adjusted. It's also a good mode to calibrate an airspeed sensor. So one of the things we do as a maiden before an auto tune as a fixed wing, when it's in its fixed wing mode and it's responding correctly, it's not a risk, I would engage loiter mode for about 5 minutes, and I would allow the airspeed sensor to calibrate, and I'll be looking at the calibration values to make sure it's done correctly, and then save those values out. The other mode on here is auto. So that would be to carry out a pre-planned mission. The mission could involve a VTOL takeoff, a fixed wing flight, and then a VTOL land, or it could just involve the fixed wing part, so you take it off yourself and transition it, and then you jump into the mission. So there's different ways to do that. And there is RTL, return to launch, or return to home. What's very nice in the version we are using, so we're on the 4.1 series of Ardu plane, is we can invoke RTL when we're far away as a plane. It will immediately turn and face us and fly back as a plane, and then it will calculate itself when to do the transition. So it will take into account wind speed as well, and it is much more accurate now to decelerating above the home point and doing an accurate return to launch. It's a very good safety feature now. So these bits we've discussed already, they're a flight mode, and they could also be assigned to a switch, like RTL could be a switch. So they're a mode. Now we've got 2 things. We've got weather vaning, and then we've got prop assist. So these are things we turn on in the parameters. So we have weather vaning, where it will turn to face into the wind. So Ardu plane is very clever. It can sense where the wind is coming for a few different ways. So it will turn into the wind, and this will be less stressful to the VTOL motors trying to hold it, and it will allow the plane to be more level. Also, so will prop assist. So for weather vaning, we enable it, and then we also set an aggressiveness as to how much it's going to and how quickly it will rotate to face the wind. This is something that's going to be very different from each plane. With prop assistance, what this will do is it will turn the front motor on to hold its position into the wind. That can be activated on a sort of strength and also a height. So at the moment this is set to about 8 meters. So once it gets to 8 meters, that front motor will come on and it will hold itself into the wind. Now that's a really good feature because instead of leaning into the wind, where you could potentially have a very high level of thrust on the rear motors, and on most, as the VTOLs get bigger, they can be sort of quite stressed anyway, the motors. So allowing it to stay flat with sort of symmetrical lift coming from your VTOL and using the front or rear motor to hold it into the wind is a very good feature for several reasons, for safety, for sort of power consumption. So I once the aircraft is flying correctly and I'm happy with the tune, I will enable both weather vaning and prop assistance, and then tweak the parameters related to those features. Prop assistance was just about that front motor, about holding that position. Cue assistance can come on in several different areas which you can choose. So it can come on when you approach a stall speed. So I have seen this happen to a customer's drone where they were able to sort of stall it by pitching up, and it was actually a way the airspeed sensor was mounted, it was given a misreading. And the cue assistance would come on and it would try to avoid a stall. You can actually trick it with reducing the throttle and fly-by-wire A, and yet holding it level, which will eventually force a stall, and the cue assistance will come in and save it. Some people like to try and land that way, but I'll leave that to the advanced people. And also it can come on if it exceeds an angle it's aiming for. So that could be because of some sort of failure, like a servo failure. So if it's not at the angle it should be at, the cue assistance can come on. So these are great features that can save an aircraft if everything's set up. I would apply cue assistance once the aircraft is set up, because also it coming on when you don't want it to, or if you've incorrectly configured it so that it's always on, you would obviously run the risk of a flat battery potentially further away. So once the aircraft's performing correctly, then add these extra bits on. Take it in baby steps, like you say.
Fantastic. So today, which of the modes that you've got set up on the model for this? Well, it's not a maiden flight because this is a model that you fly regularly. But assuming it was a maiden flight, which modes would you recommend going to the field with out of those that we've looked at then?
Yeah. So in our pretend maiden flight today, we will we'll simulate it exactly how I set it up. So the fixed flight modes on here, or how I would use this for the maiden and in real life, I will invoke. So we'll connect. We'll have a laptop in the field. We'll be connected by either Wi-Fi or USB tether, and I will initially, what you'll see us do, we'll carry out a motor test. Then we will do the cue stabilize hover, and that will just be selected from a mission planner, not from the remote, because I don't want to accidentally go into that mode. Once we're happy with that, once we've observed it behaving correctly, well then we have already on the sticks here cue hover, cue loiter, fly-by-wire A, fly-by-wire B. And the way I've set them up on here, we've got a short press and a long press. Again, short and long. I do also use the normal Tyrannus or Radio Master radios, and I'll normally need all sort of 6 switches. That might be a combination of 2. I have done it before with just a 3 position switch. If I know I'm going to go from, say, cue hover to fly-by-wire A, and then maybe auto, depending on the aircraft.
So again, massive thank you to Ben for spending the time to explain that. Join me in the last final video in this series where we'll actually go through the maiden and you'll see this thing in the air. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that if you're trying to learn a topic will take you from the basics right the way through to some pretty advanced stuff.